Good afternoon, my YouTube viewers. It is Crystal here, and I'm just here because I want to do another code review for you. But before I do the code review, I want to go over some what the Poisson distribution is, because we're going to be talking about the Poisson distribution in this code review. So I just looked on the internet to find out what a Poisson distribution is, and it says the Poisson distribution is the discrete probability distribution which represents the probability of occurrence of an event or number of times in a given interval of time or space if these events occur with a known constant mean rate and are independent of each other. This type of probability is used in many cases where events occur randomly but with a known average rate. The number of events that happen during an interval is dependent on the time elapsed rather than the total time available. The Poisson distribution can be applied to time-sensitive processes such as text messages sent per minute and phone calls received per second. Poisson distribution can help us determine how often we may expect an event, such as finding customers in line or the number of accidents that occur per hour. The following are the key criteria that the random variable follows the Poisson distribution. Individual events occur at random and independently in a given interval. This can be an interval of time or space. The mean number of occurrences of events in an interval, time or space is finite and known. The mean number of occurrences is represented using a lambda. The random variable x represents the number of times that the event occurs in the given interval of time or space. If a random variable x follows the Poisson distribution, it is represented as the following. So you've got x and the little tilde and PO with the lambda. In the above expression, lambda represents the mean number of occurrences in a given interval. Mathematically, the Poisson probability distribution can be represented using the following probability mass function. So they give you the formula right there. In the above formula, the lambda represents the mean number of occurrences. R represents the different values of a random variable x. And then it just goes on and tells you more about the Poisson distribution that you can read on your own if you're really interested. But what we're going to do is we're going to do the code review, and we're going to compare the Poisson distribution to the binomial distribution. So the first thing we're going to do is we're going to make the binomial distribution. So binomial is going to be an empty array for I in range 100,000, n equals 1,000, probability equals 1 over 1,000. And flip equals np.random.binomial np, and then you add the flip, you append the flip to the binomial. We create a histogram of it, so you can see the histogram right here of the binomial. And so now we take binomial, we convert it to a series using pandas, and we print the mean, which is 0.99. We print the variance, which is 0.99, and we print the standard deviation, which is 0.999. So you've got your mean, your variance, and your standard deviation. So that is a distribution created with the binomial. And so now what we're going to do is we're going to create a Poisson distribution. So we have to import pandas as PD, import scipy.stats, and import Poisson, and import Seaborn as SNS. So Poisson equals Poisson.rvs. Mu is your mean, which is 1, and the size is 100,000. So Poisson equals PD.series Poisson, and we make the histogram, and you can see the histogram is very similar to the histogram that we created previously. And so now what we're going to do is we're going to compare the distribution of compare the distribution with the binomial with the distribution of the Poisson, and you can see it's the same. You can see because I made a red was the binomial and the blue was the Poisson, and you can see that the red and the blue overlap each other. So that means that the distributions are the same. So we create a bunch of distributions, and with the size of 100,000, but we change the mu from 0.1 to 1 to 5 to 10 and 100. And then we create a data frame out of all of these flips. Flips 1, flips 2, flips 3, flips 4, flips 5. And then, so you can see flips 1 has a mu of 0.1, so you can see it's mostly 0. Flips 2 has a mu of 1, so you can see that it's increased. Flips 3 has a mu of, I believe, a 10, so you can see again it's starting to take on a bit of a shape of a distribution. Flips 4, let's see what we had. We had, oh, one was 5. This must have been 5. And this is 10. So it's taking on more of a distribution. And flips 5 is 100. And so you can see that it looks like a binomial or a normal distribution when you increase the mu. So as you increase the mu, the distribution changes shape. So that's what we wanted to do. But what I want to do here, because I sort of forgot to do something, so so now what we're doing is we're just rerunning the program. So it'll take just a little while to rerun it. So I don't know what its problem is, why it's not rerunning it. We'll just try it again and try to get it to run. Okay. So we reran it. It finally worked. So we've got our deviation of the binomial distribution of mean is 0.99, variance is 0.99, and standard deviation is 0.99. So now we're going to check the Poisson. The mean is 0.99, the variance is 0.99, and the standard deviation is also 0.99. That's what I wanted to do. I just wanted to check the metrics. And you can see here that the binomial and the Poisson follow pretty much the same pattern. And then you can see here that the higher the mean, the more the distribution takes on more of a normal distribution shape. So we're going to go ahead and conclude this video because we've talked about the Poisson distribution, and we've compared the Poisson distribution with the binomial distribution. And so you see that you can create a Poisson distribution with a binomial, and you've seen that. So I'm going to go ahead and conclude this video now. So thank you so much for watching my video. If you like it, please like, subscribe, and share. And I would also like to thank my subscribers for supporting my channel.